An induced EMF has no direction of its own. Comment. Now, in order to understand this, okay, we consider Lane's law, and we know according to Lane's law, the direction of induced EMF or induced current, okay, in a circuit is such that it opposes the change in magnetic flux. So we have this, okay. Now, if the flux linked or crossing, okay, or passing through the coil is decreasing, then the induced current flows in such a direction so as to produce magnetic field or magnetic flux, okay, in the same direction of the external field, or let me write in this way, external field or flux. So we need to note this, okay. If the flux linked or crossing through the coil is decreasing, okay, then the induced current flows in such a direction so as to produce magnetic field or flux in the same direction as external field or flux. So we have this. Now, I'm writing over here. If the flux linked or crossing, okay, through the coil is increasing, so we have this, then the induced current flows in such a direction, okay, so as to produce magnetic field or magnetic flux in the opposite direction, okay, in the opposite direction of the external field, that is magnetic field, or external magnetic flux. So therefore, okay, so therefore we can conclude, okay, we can see the induced current, okay, can flow in any direction in the circuit, okay. So it can flow in any direction in the circuit. So what we find in this case, if the flux link or crossing through the coil is increasing, then the induced current flows in such a direction so as to produce magnetic field or flux in the opposite direction of the external field. So in the circuit, induced current can flow in any direction. That is, it can flow in clockwise direction or it can flow in anti-clockwise direction. So we can conclude that induced EMF, okay, has no direction of its own. So we have this, okay, induced EMF and hence induced current has no direction of its own.